एक मिल गया था
मिल गया
और वो कोड लेके आता
हाँ
नेट की स्पीड तो अच्छी आ रही है, क्या कर रहे हो?
डबल डबल निकालना
Now, once again, welcome to Dr. Ahmed Zahir lecture series. First of all, I welcome Principal Dr. Mazhar Ahmed Farooqi, IQSC coordinator, Professor Aditi Bhattacharya, Vice Principal M.A. Bari, Series Coordinator, Professor Syed Sultan, and today's speaker, Mr. Dr. Abdul Ahad, Department of Chemistry, Maulana Azad College, and dear students and teachers. Today's speaker is Dr. Abdul Ahad. He is going to speak on the topic organic compounds of nitrogen. Before starting his lecture, I request Dr. Ummul Khair Asima, Department of Chemistry, Associate Professor, Department of Chemistry, Maulana Azad College, Aurangabad, to introduce him.
Thank you very much, Arif sir. Most respected Principal of Maulana Azad College, Dr. Mazhar Ahmed Farooqi sir, and President of this lecture series. Beloved Vice Principal, Dr. M.A. Bari sir, IQAC Coordinator, respected Aditi Bhattacharya ma'am, Convener of this lecture series, respected Professor Arif Pathan sir, and the Program Coordinator of lecture series, respected Professor Syed Sultan sir. It gives me an immense pleasure to introduce today's resource person of this Dr. Ahmed Zahir Memorial Lecture Series, Dr. Abdul Ahad. Dr. Abdul Ahad holds a PhD and MPhil in chemistry. He has gained 16 years of teaching experience to undergraduate and postgraduate students. He is a very good researcher and has, to his credit, 30 publications in various national and international journals of high repute. He is a very active and an enthusiastic guy and has attended a number of seminars, workshops, and conferences. I would like to add here that he is a very helpful, humble, and a very good human being. The topic of the talk is organic chemistry, organic compounds of nitrogen. Over to you, Arif sir. Thank you very much.
Thank you, Asima madam. Now I request Dr. Abdul Ahad to deliver his talk.
Yes, sir. Hello everyone. I am Dr. Abdul Ahad, Assistant Professor, Maulana Azad College, Aurangabad. I welcome respected Principal, Dr. Mazhar Ahmed Farooqi sir, Vice Principal, Dr. M.A. Bari sir, the convener of this Dr. Ahmed Zahir lecture series, Dr. Arif Pathan sir, coordinator Dr. Syed Sultan sir, and all the participants. I am here to deliver a presentation on the topic organic compounds of nitrogen as part of Dr. Ahmed Zahir lecture series. In my today's presentation, my focus will be on to explore various types of organic compounds of nitrogen, particularly the nitro and amines compounds in context with the BSc syllabus. because we cannot cover the chemistry of all the nitrogen compounds in a single lecture. So we are going to see the structure and reactivity of nitro compounds and amines, their methods of preparation, their different chemical reactions, preparation of their derivatives, and also mechanism of some important reactions.
हाँ सर, 1 मिनट का पॉज लीजिए और रीस्टार्ट कीजिए, वो कीजिए, अनम्यूट करना दोबारा से। मैं सबको तक हाँ अनम्यूट कीजिए और स्टार्ट कीजिए। वो दूसरे पे अनम्यूट करना है, सिर्फ ओनली अनम्यूट।
ओके सर,
हाँ ठीक है, ठीक है, ठीक है।
may I start?
हाँ बिल्कुल बिल्कुल।
As we know that nitrogen is a non-metal and the lightest member of group 15 of the periodic table, and nitrogen occurs in all the organisms, that is amino acids, the building blocks of protein. Their amines are also available in DNA and RNA. We can see here the part of different structures of DNA, RNA, in which thymine, cysteine, guanine, all these are the parts of DNA and RNA chain, and they all contain nitrogen atom in their heterocyclic framework. In another diagram, we can see different essential amino acids like valine, leucine, okay, methionine. They all contain nitrogen atoms in their structure. Another structure we can see here, a structure of porphyrin. It is a hemoglobin structure. We know that hemoglobin and myoglobins, they are oxygen carrier and they transport the oxygen. So they also contain nitrogen atom in their structure as part of this pyrrole ring, as part of this porphyrin ring. Similarly, the chlorophyll, which is a green pigment used for photosynthesis, it also contains the nitrogen atom in its structure. Okay, different alkaloids available in various plants are also having nitrogen atom as part of organic structure. We can see here different drug molecules like paracetamol, isoleucine, nimesulide. All these drugs are having different types of. All these drugs are having, like paracetamol, it is having analgesic, antipyretic activity. Isoleucine, it is also used for relief of pain. It is having anti-inflammatory and analgesic activity. Similarly, nimesulide, it is also a painkiller. All these drugs contain nitrogen atom in the form of various functional groups. In this slide, we can see different drugs like antidiabetic drug, narcotic, analgesic drug, and sedative. All these drugs also contain nitrogen atom in their structure in the form of heterocyclic ring. So overall, we can say that there is a huge importance of this nitrogen atom containing organic compounds. So we are going to study here different types of nitrogen atom containing functional groups. Nitrogen atom is present in the form of various types of functional groups. We can see here it can be present in the form of nitro group, amine group, nitrile group, or amide group, amino acid, polyamides, azo, hydrazone, urea, imine, etc. But in today's lecture, we will only cover the nitro compounds and the amine compounds. Okay. Or I would say we will uncover these two functional groups. We are going to see the different methods of preparation of this nitro compound, their different reactions, preparation of their derivatives, and also mechanism of some of the important reactions. So first we will start from nitro compounds. Nitro organic compounds containing NO2 group, NO2 functional group, nitro group are of two types. The first one, that is aliphatic nitro compound, and the second one, that is aromatic nitro compound. in aliphatic nitro compound, the nitro group, it is attached with the R group, and this R group may be methyl, ethyl, propyl, or any alicyclic group. So this R group here, it is an aliphatic group. And in aromatic nitro compound, the nitro group is attached to an aromatic system. So this aliphatic nitro compound, we can see here a structure of nitromethane. In this nitromethane structure, we can see there is a methyl group, and this methyl group is having acidic alpha hydrogen atom. So when this nitromethane is react with a strong base, then it will lose its proton to this base, and formation of a carbon ion intermediate takes place. Now this carbon ion will be stabilized by resonance, because this NO2 group, it provides the conjugation to this anion, and it stabilizes this anion. So therefore, this alpha proton of nitro with respect to nitro group, it is having acidic character. So this is the reactivity of this nitroalkane, and because of this acidic character, we can utilize this nitroalkane in various types of chemical reactions. So first we will see the different general methods of the preparation of these nitroalkanes. We will see the preparation of nitroalkane by nitration of simple alkane, and by from alkyl halide, we can also prepare this nitro compound by primary amine, oxidation of this primary amine, and also we can synthesize them by from oximes. The first method of preparation of nitroalkane is nitration of alkane by reacting it with fuming nitric acid at higher temperature. Okay, so this reaction gives a number of nitrated product, a number of nitroalkane. We can see here we are getting a different nitroalkane, primary nitroalkane, secondary nitroalkane. Okay, so we are getting here a mixture of different nitro products, a mixture of different nitroalkane. And as far as the mechanism is concerned, the mechanism proceed through a radical intermediate. Okay, and we know that the radicals are very reactive in nature. Therefore, we are getting here, after recombination of these different radicals, we are getting here different products. Okay, so this method of preparation is of less important, because we are getting here a mixture of different nitrated or product or nitroalkanes. Another method of preparation of this nitroalkane is from alkyl halide. We can prepare this nitroalkane from the reaction of alkyl halide and silver nitride. This alkyl halide and silver nitride, when they react together, they form this nitroalkane and silver halide as a product. Okay, so we can prepare here different we can prepare nitroethane by the reaction of ethyl iodide and silver nitride in this example. Another type of method of preparation of nitroalkane is oxidation of tertiary butylamine with an oxidizing reagent like KMNO4. In this, we can see we are using here tertiary butyl alkylamine, in which this amino group is having primary nature. When it is oxidized with an oxidizing reagent KMNO4, then oxidation of this NH2 group takes place, and we will get here NO2 group. So after oxidation of this tertiary butyl alkylamine, we will get here the tertiary butyl nitroalkane. Okay. In the next method of preparation, we can see here we can obtain different nitroalkanes. That is, we can prepare here primary nitroalkanes also, and we can prepare here secondary nitroalkane also. So in this method, these nitroalkanes are prepared by the oxidation of aldoxime and ketoxime by using an oxidizing reagent like trifluoroperoxyacetic acid. This trifluoroperoxyacetic acid oxidizing reagent, it will perform the oxidation of this aldoxime, and it gives the corresponding primary nitroalkane. Okay, aldoxime, we know that this aldoxime can be prepared by the reaction of aldehyde and hydroxylamine, whereas ketoxime, they are prepared from the reaction of ketone and hydroxylamine. So this ketoenzyme, after oxidation with this peroxyacetic acid, it gives the secondary nitroalkane. Okay. Now this all reactions are about method of preparations of this nitroalkane. Now we will see one by one some of the important chemical reactions given by this nitroalkane. These nitroalkanes, they give different types of chemical reactions, like they undergo hydrolysis, they undergo reduction reaction also, we can perform different halogenation reaction and condensation reaction with different aldehydes to these nitroalkanes. Okay, this first method of this first reaction, we can see here this nitroalkane, when it reacts with bromine in alkaline media, we are using here in this halogenation process, we are using here bromine with sodium hydroxide. We know that this H2 group of nitroalkane, it is having acidic character. So this sodium hydroxide, which is acting as a base here, it will abstract this proton of this alpha hydrogen atom, which is having acidic character, then formation of a carbanion intermediate, and this carbanion intermediate will attack on this bromine to give this mono halogenated product. Okay. So this reaction will not stop here. This intermediate contain one more acidic alpha hydrogen atom. So it will again react with second atom of bromine, second molecule of bromine, and we will get here this di-bromo nitro product. Okay. In this example, we can see it is a secondary nitroalkane and it is having only one alpha hydrogen atom. So in this reaction, monohalogenation takes place. Whereas in this tertiary nitroalkane, there is no any acidic hydrogen atom. Therefore, bromination reaction will not take place for this substrate. Okay. So as far as the reactivity is concerned, as we know, this alpha group, alpha carbon atom is having acidic hydrogen atom. So it also undergoes aldehyde, it also undergoes aldol type reaction. Okay. So aldol, in the aldol reaction, we know that the ketone and aldehyde, they react in presence of acid or a base catalyst. So here also, in the presence of base, the nitromethane, it will lose the proton to this base and form a carbanion intermediate. And this carbanion intermediate, it will attack on the carbonyl carbon of this aldehyde. And after protonation, it will form a nitro alcohol. Okay, so overall, we can say that we can prepare nitro alcohol by the reaction of nitroalkane and aldehydes. The next reaction for nitroalkane is hydrolysis. In the hydrolysis of this nitroalkane, we will get here different types of product. That is, we can obtain here acetic acid also, we can obtain here acetone also. If we are using here primary nitroalkane, then if we perform the acidic hydrolysis of this primary nitroalkane in presence of HCl and water, then acetic acid will be the product here. If the nitroalkane, which is having secondary nature, in this second example, we can see the nitroalkane is attached with a secondary carbon atom. So this compound, this structure, after acidic hydrolysis, it gives the corresponding acetone. Okay. Whereas the tertiary nitroalkane, after hydrolysis, do not give any product. Means there will be no any reaction. Okay. So for the hydrolysis of this nitroalkane, there must be again alpha hydrogen atom should be there. Okay. Primary nitroalkane gives acetic acid and secondary nitroalkane gives ketone, whereas tertiary nitroalkanes do not give any reaction. The next reaction of nitroalkane is action of heat. When nitroalkanes, they are heated at 573 Kelvin, then they give this alkene. They will give alkene and a nitrous acid as a byproduct. Next type of reaction we can see in this slide is a Manich reaction. We know that the Manich reaction, it is a reaction of an of a ketone or any active group with an aldehyde and amine. Okay, and in this reaction, amino alkylation reaction takes place. So we can utilize here, instead of ketone, we can use here nitromethane as an active group because it is having this alpha hydrogen atom which is having acidic character, and by this multi-component Manich reaction, the amino methylation reaction of this alpha carbon atom takes place. Okay, so this is a multi-component reaction by which we can prepare different Manich bases. Now, the second category of this nitro compound is nitroarenes. Nitroarenes are those compounds in which the nitro group is attached to the arene, to the aromatic ring. Okay. So in the preparation, we can see here, we can prepare this aromatic nitro compound by the nitration reaction of aromatic compound. We can use here benzene, naphthalene, or any other aromatic compound. Okay. So for the nitration process, we can utilize here a nitrating mixture like nitric acid and sulfuric acid. We can also use here fuming nitric acid also as a nitrating reagent, and we can also use here some nitrogen oxide for nitration purpose. As far as the mechanism is concerned, we can see here for the nitric acid and sulfuric acid, they react with each other in an acid-base reaction manner, and the sulfuric acid, it will give its proton to nitric acid and formation of OH2 plus will take place, which is a good leaving group. After removal of this leaving group, water molecule, the formation of nitronium ion takes place. Now this nitronium ion, it will react as an electrophile. Okay, in the next step, this nitronium ion, which is having electrophilic character, it will attack by the pi bond electrons of benzene, and the formation of a carbonium ion intermediate takes place. Formation of a carbocation intermediate takes place. And this carbocation intermediate is stabilized by resonance. This carbocation intermediate is also called as arenium ion intermediate or benzonium ion intermediate. Okay, so here the aromaticity of this benzene is lost. Okay, but it is stabilized by somewhat by the resonance. Then after removal of proton by this sulfide, hydrogen sulfide ion, this will react as a base now, and it will abstract one of the proton here, and it will form the stable aromatic ring again. So overall, we are getting here nitrobenzene as a final product from benzene. These are some of the examples of nitration of different substituted benzene, in which we can see here the toluene or methylbenzene, when it react with nitric acid and sulfuric acid, it gives two compounds, orthonitro compound and then paranitro compound. We know that this methyl group, it is having a plus I effect, and it is having ortho and para directing nature towards electrophile. So it will attract the electrophile nitronium ion at ortho position and para position. Therefore, we are getting here these two products, ortho product and para product. In this example, we can see the nitration of nitrobenzene. Okay, so when the nitration of nitrobenzene is performed in presence of this nitric acid and sulfuric acid, again this nitronium ion formation takes place, and this nitronium ion will be attacked by the pi bond electron of benzene. Okay, so here we can see the nitro group, which is already present on benzene. It is having electron withdrawing character. It is having meta directing character towards electrophile. So it will attract this nitronium ion electrophile at meta position, and we will get here the meta dinitro benzene as a final product. Now, we are going to see the different reactions of aromatic nitro compounds. The aromatic nitro compound, they undergoes catalytic reduction. The catalytic reduction takes place in presence of metals such as iron, tin, or zinc with strong acidic condition. Or this reduction process can also be performed by using the metals like iron, tin, platinum, platinum, or nickel catalyst in presence of hydrogen. So overall, this NO2 group will be converted into amine group by this reduction reaction. In this slide, we can see the reduction of nitro compound in acidic, alkaline, and neutral medium. Okay. So these reactions are given by some of the reactions are also given by nitroalkanes also. Okay. We can see here the nitromethane after reduction with zinc and ammonium chloride. Ammonium chloride, it is having neutral character. It is a salt here, and it offered the N-methyl hydroxyamine as a final product. Again, the nitrobenzene after reduction of zinc with ammonium chloride, it again gives the hydroxylamine as a final product. All these reactions are taking place in neutral medium. Okay, but if we perform this reaction in acidic medium, means if instead of ammonium chloride, we are utilizing here acidic condition, we are using here HCl. So what will be the product? The product will be aniline. Nitrobenzene will give here aniline as a product. Whereas in neutral condition, the nitrobenzene gives here hydroxylamine as a product. In the basic medium, the nitrobenzene gives different products in different conditions. We can see here in the reduction of nitrobenzene, if you use zinc metal with aqueous solution of sodium hydroxide, then the hydrazobenzene will be the product here. Whereas if we utilize zinc with alcoholic sodium hydroxide solution, then azobenzene will be obtained as a product. Okay. And if we use sodium arsenide and sodium hydroxide or glucose with sodium hydroxide, then azoxybenzene will be the final reduced product here. The reduction of this NO2 group can also be performed by another hydride ion reducing reagent, that is lithium aluminum hydride. These reactions perform in anhydrous condition, we can see here in ether. So nitromethane after reduction with lithium aluminum hydride, it gives methylamine as a final product. Whereas nitrobenzene, this nitrobenzene, when it allowed to react with lithium aluminum hydride and a Lewis acid catalyst like titanium chloride here, then we will obtain here aniline as a product. But the same reaction, if we perform without this Lewis acid catalyst, and if we use a lithium aluminum hydride 5 mole equivalent, then the product will be azobenzene. Another type of reaction given by nitroarenes is nucleophilic substitution reaction. In this nucleophilic substitution reaction, we can see here the nucleophile is attacked on this carbon atom where the fluorine group is attached, and this fluorine group is acting as a leaving group here. So what is the reactivity of this parafluoro, or we can say parafluoronitrobenzene? In this structure, we can see here NO2 group it is having electron withdrawing character. It is having minus I effect also. It is having minus M effect also, or minus R effect also. So it will decrease, this nitro group will decrease the electron density on ortho position and para position. Or overall, we can say that it increases the electrophilic character of this para position. So overall, because of this nitro group, the electrophilic character of this carbon atom will increases where this leaving group is attached, and the attack of this OH group will be easy. Okay, so if nitro group is present on benzene at proper position, then it will enhance the rate of any nucleophilic aromatic substitution reaction. Okay, so in this mechanism, we can see the OH group will attack on this carbon atom where this fluorine leaving group is attached, and we will get here an intermediate carbon ion intermediate. So this NO2 group is also helpful for the stabilization of this carbon ion intermediate by forming a Medenheimer intermediate. Then in the last step, the removal of this fluorine group will take place on formation of the final nucleophilic substituted product, that is para-nitrophenol takes place. The next functional group of amine we are going to study here is the nitrogen compound we are going to study here is amine. We can see here amines are of three types: primary amine, secondary amine, and tertiary amine. Further, these amines are further classified in aliphatic amines, aromatic amines, and heterocyclic amine. In aliphatic amine, the groups which are attached to the nitrogen atom, they are having aliphatic nature like methyl, ethyl, propyl, or alicyclic groups. Okay, but in aromatic amines, the amine group, NH2 group, which is attached to the R group, it is having, this group is having aromatic character. So we can see here aniline, it is a primary amine; methylamine, it is a secondary amine; and methyl aniline and dimethyl aniline, it is a having tertiary nature. Another category of amine is heterocyclic amine. In this category, in the cyclic structure of carbon atom, that is in the carbocyclic structure, one of the carbon atom is replaced by nitrogen atom. So we can see here in this slide different heterocyclic amines like pyrrolidine, piperidine, pyrrole, pyridine, pyrimidine, etc. Some of them are aromatic and some of them are non-aromatic. Now we will discuss in brief the basicity of amine. The basic strength of amine, we know that the amine is having nucleophilic character as well as it is having nucleophilic character, and the basicity and the nucleophilicity of this amine is depend on the electron availability on nitrogen atom. The basic strength of amine is depend on the inductive effect of the substituents, the degree of solvation, and steric hindrance. These three effects are responsible for determining the basicity of any amine structure. We can see here in the gas phase, only inductive effect is matter here. The 3-methyl groups which are having plus I effect, so they will increase the electron availability on nitrogen atom. So therefore, trimethylamine is a strong base as compared to this secondary amine or primary amine. But this order will be in gas phase only. If we study the basicity of this amine in solution phase, then what will happen? If the nitrogen atom is attached with methyl group, then dimethylamine will be stronger base as compared to methylamine than trimethylamine. So we can see here this trimethylamine, it is weak base. इतना वीक बेस है कि ये जो है तो प्राइमरी अमाइन से भी ज्यादा जो है तो ये यहाँ पे वीक बेस का कैरेक्टर शो कर रहा है. ओके, सो दिस इज द ऑर्डर of basicity if the nitrogen is attached to methyl groups. If this nitrogen atom is attached to ethyl group, then again the order will change. In solution, we are studying here in the basicity of amine in solution in aqueous phase or in protic solvent. So if this nitrogen atom is attached with ethyl group, then the secondary amine will be the more stronger as compared to tertiary amine and then primary amine. So this is these values of basicities are observed experimentally, and this basic order can be determined, can be judged by utilizing or with the help of all this effect, in combination of all this effect, that is inductive effect, solvation effect, and steric hindrance. So this is all about basicity of simple aliphatic amine. Now the basicity of aryl amines. Aryl amines are much less basic than alkyl amines. Why? We can see here the aryl amines are having pKb value 10, whereas alkyl amines are having pKb value 4. So we can see here the aliphatic amines or alkyl amines, they are much stronger base than aryl amine. Why? Because there is less electron availability of these two nitrogen atom. है ना, इलेक्ट्रॉन पेयर होता है ना यहाँ पे नाइट्रोजन के पास में, तो इसकी अवेलेबिलिटी नाइट्रोजन के पास कम होती है. Why? Because of the delocalization of this electron. These electrons, these two electrons, this pair of electron of or we can say the non-bonding electron of this nitrogen atom, they are delocalized in the aromatic ring, and the phenomena that is resonance taking place here. So this electron pair are utilized in resonance. So therefore they are not readily available on nitrogen atom to uptake a proton or to form to act as a nucleophile. Therefore these aromatic amines are less basic as compared to these aliphatic amines. Okay. In this table we can see the basicity order of different aromatic amines. In this aniline structure, if this Y group is having electron releasing character or it is having activating character, then it will increase the electron availability on this nitrogen atom. Therefore, the electron releasing group present at proper position on aniline aromatic ring, then they will be more basic. Whereas if the electron withdrawing groups are present, then they will decrease the basic character of this aromatic amines. As we can see here in this slide, the amines are having acidic character. Therefore, by this using this property, we can prepare different salt of these amines by reaction with acid, and by using this particular reaction, we can separate these amines from a variety of mixture. We can separate the bases, this aniline from neutral compound. We can separate them from phenol. We can separate them from acids also. So we are not we will not go into detail of this separation process. Now we will see the different methods of preparation of these amines. The first method of preparation used for the preparation of amine is alkylation of ammonia using alkyl halide. We can see here in this reaction, the alkyl halide, when it reacts with ammonia, it gives methylamine. But this reaction do not stop here. This methylamine further react with another molecule of alkyl halide, and it gives the secondary amine, that is dimethylamine. This dimethylamine again, it react with another molecule of alkyl halide, and it gives the corresponding trimethylamine. And this trimethylamine, it react with another molecule of alkyl halide, and we will get here tetramethyl ammonium bromide, or it is also called as quaternary ammonium salt. So overall we can say that we are getting here a number of products. Agar hame yahan pe, if you want to prepare this product, or if you want to prepare only this product, so we cannot stop this reaction at only one stage. Further alkylation will take place, and this is the limitation of this reaction. What is the limitation? We can see here this method is having limitation because multiple amination reaction takes place here. The next method of preparation for amine is a name reaction, that is Gabriel amine synthesis. In this Gabriel amine synthesis, the phthalimide is allowed to react with potassium hydroxide or a sodium hydroxide and alkyl halide and hydrazine hydrate. Okay, and it gives the corresponding primary amine as a main final product, and phthalazine 1,4-diene as a byproduct. In the mechanism we can see here, in this phthalimide structure, this nitrogen atom is attached with an hydrogen atom which is having acidic character. So this strong base, potassium hydroxide, it will abstract this acidic hydrogen atom, and from phthalimide, formation of potassium phthalimide takes place. In this potassium phthalimide, this nitrogen atom is having nucleophilic character, and it will attack on this carbon atom of this alkyl halide, and simple removal of this leaving group, that is halogen group, takes place. So in this step, the mechanism proceeds through SN2 manner, in which the bimolecular nucleophilic substitution reaction takes place, and this nitrogen atom of this potassium phthalimide, it will attack from the back side of this halogen group. Okay, so here in this step, alkylation of this nitrogen atom takes place, and we will get here N-alkyl phthalimide as a intermediate. Now this N-alkyl phthalimide is allowed to react with hydrazine hydrate. Then this hydrazine hydrate, it will attack on one of the carbonyl carbon atom of this phthalimide, and it will decompose this 5-membered ring, and after removal of this primary amine group, it gives phthalazine 1,4-dione as a byproduct and primary amine as a main final product. So we can prepare here, by the reaction of this phthalimide, we can prepare here primary amine by using this Gabriel amine synthesis. In this reaction, we can see here in this slide, we can prepare different amines by reduction reaction. We can use here the reducing reagent like metal, hydrogen, or metal with acid. In another type of reduction process, we can prepare here meta-nitroaniline by doing a partial reduction of nitro group. Here 2 nitro groups are there, and this ammonia and hydrogen sulfide reagent, they reduce only one NO2 group and gives the meta-nitroaniline as a product. Now, in this reaction, we can see the preparation of amine from aldehyde or ketone. In this reaction, it is a 2-step reaction, in which in the first step, the aldehyde or ketone, they allow to react with amines, either ammonia or primary amine or secondary amine, in presence of acid catalyst. So they give the corresponding imine. In the mechanism, you can see amine and aldehyde or ketone, they react together to form an unsaturated C double bond N bond, which is called as imine, or which is also called as cheap bases. Then after reduction of this cheap base, we will get here different amines, different substituted amines. So for the reduction of these cheap bases, we can use here different reducing reagent. We can use here hydrogen with metal, nickel, platinum, palladium. We can use here lithium cyanoborohydride. We can use here sodium cyanoborohydride as reducing reagent for the conversion of, or for the reduction of this imine to amines. Now, the same reducing reagent can be used for the preparation of amine by the reduction of different other functional group. Like in this first example, we can see the reduction of this hydroxylamine takes place in presence of sodium and ethanol to give this primary amine. In the second example, this 2-phenyl ethanonitrile, when it gets reduced with hydrogen and Arane nickel as a catalyst, it gives the corresponding 2-phenyl ethanamine as a final product. In this next example, we can see here, this is the structure of amide. When this amide is allowed to react with lithium aluminum hydride, then the reduction of this amide takes place, and we will get here this amine as a final product. Now the next method of preparation of amine is Hoffman method. which is also called as a Huffman-Bromide reaction or Huffman rearrangement. In this Huffman rearrangement of Huffman reaction, the amide is reacted with bromine in alkaline media, and after removal of carbon dioxide, the formation of amine takes place. In the mechanism, we can see here the amide, when it reacts with strong base and bromine, it forms an anhaloamide intermediate. This anhaloamide intermediate, which is having one more acidic proton, this acidic proton will be abstracted by sodium hydroxide, and formation of anhaloamide anion takes place. Now this anhaloamide anion, after migration of this R group from this carbonyl carbon to nitrogen atom, and after removal of this bromine group, the formation of this isocyanate intermediate takes place. This isocyanate intermediate, when it reacts with water molecule, and after removal of this carbon dioxide gas, it gives the corresponding amine as a final product. In the next method of preparation, the amines can be prepared, primary amines can be prepared by the reaction of chloramine with Grignard reagent like methyl magnesium bromide, and the product will be methylamine, and magnesium chlorobromide will be the byproduct here. In another method of preparation of amine, these amines, the quaternary ammonium salt of amine, when they allow to react with moist silver oxide, that is silver hydroxide, then it will form silver quaternary ammonium silver hydroxide salt, which after heating gives the corresponding trialkylamine. Okay, so this was all about the preparation of these amines. Now, in the last part, we are going to see different types of chemical reactions given by this amine. These amines undergoes various types of reactions like alkylation reaction, acylation reaction, electrophilic and nucleophilic substitution reaction. This amine also undergoes oxidation and coupling reaction. In the first reaction, which we have seen already, the alkylation of this amine takes place, and we will get here different from methylamine, from primary amine to secondary amine, from secondary amine to tertiary amine, and from tertiary amine, when it reacts with this alkyl halide, we can get here different, we can get here the tetramethyl ammonium bromide, that is quaternary ammonium salt. In the next reaction of amines, we can prepare here different amide derivatives. We can prepare here these amide derivative by the reaction of these amines, primary amine or secondary amine, by reacting with acid halide. In the mechanism, we can see here the lone pair electron of this amine, it will attack on the carbonyl carbon of this acid chloride, and after removal of this chlorine group and this hydrogen atom, we will get here an ethylenamide as a final product. So this reaction is useful for the conversion of amide from amine, and these reactions are usually performed in basic medium, like we can use here potassium carbonate, we can use here pyridine as a base catalyst. Amines also acylated, they can acylated by acetic anhydride also. We can see here this para-aminophenol is acylated by using another acylating reagent, that is acetic anhydride, and we will obtain here this para-acetamidophenol, that is paracetamol, as a main final product. So this method of preparation is used for the preparation of paracetamol, and we know this paracetamol is having analgesic, and it is used most widely used for treatment of fever and pain. It is a painkiller drug also. So in this mechanism, we can see the lone pair of electron of the nitrogen atom, or the nitrogen atom will attack on one of the carbonyl carbon atom of this acetic anhydride, and removal of this acid toxic group will take place, and simple acetylation takes place, and formation of this paracetamol will be there. another type of reaction given by amine is a formation of amide by using DCC as a reagent. Okay. So what is the reaction here? In this reaction, it is a coupling reaction. It is a coupling reaction in which amine and acid, they couple together to form an amide as a final product. Okay. So for this amide preparation by using amine and carboxylic acid, we required a coupling reagent here. Why? Because we know that amine is having basic character and this carboxylic group is having acidic character. So simple acid-base reaction will take place there, and we will get there a salt, unreactive salt. So to prevent the formation of this salt, we use here a coupling reagent like DCC. What is the full form of DCC? It is called as 1,3-dicyclohexyl carbonamide. Now, in the mechanism, in this slide, we can see here the DCC, which is having basic character, it will first abstract the hydrogen atom of this acid, which is having acidic character. Okay. Now, formation of acetoxy intermediate takes place. In this intermediate, this carbon ion, this negative charge on oxygen atom, it is having full-fledged nucleophilic character. So it will attack on the central carbon atom of this DCC, and formation of this intermediate takes place. Now, in this step, the introduction of amine takes place. This amine, it will attack as a nucleophile here. यहाँ पे अब अमाइन क्या कैरेक्टर क्या हो गया? न्यूक्लियोफाइल कैरेक्टर है यहाँ पे. ये यहाँ पे प्रोटॉन ऑब्स्ट्रक्ट नहीं कर रहा है. इट इज एक्टिंग एज अ न्यूक्लियोफाइल. ओके. तो अब यहाँ पे क्या करेगा? ये अटैक करेगा ये कार्बोनिल कार्बन के पास, ये कार्बन के पास में, एंड फॉर्मेशन ऑफ नेगेटिव चार्ज ऑन ऑक्सीजन टेक्स प्लेस अगेन, एंड आफ्टर अगेन back bonding of this oxygen atom to form carbon oxygen double bond takes place, and removal of this overall group takes place. So it is, this group is a good leaving group. Okay. So here after removal of one of the proton, it gives the corresponding amide as a final product. And what will be the byproduct here? Dicyclohexyl urea will be the byproduct in this reaction. So overall, by using this DCC, we can easily prepare or synthesize different amides by the reaction of amine and carboxylic acid. This reaction is particularly used in industries for the preparation of peptides. Another reaction given by amine is a type of nucleophilic substitution reaction. In this slide, we can see here the aromatic amines, different aromatic amines, when they allow to react with a nitrous acid. How we can get this nitrous acid? This nitrous acid can be prepared by the reaction of sodium nitrite and HCl. During the reaction, they react together and give this HNO2 nitrous acid. This nitrous acid is also called as in situ reagent. Why? Because it is not stable, तो हम इसे बना के स्टोर करके नहीं रख सकते. तो यहाँ पे हम HNO2 को ड्यूरिंग रिएक्शन प्रिपेयर करते हैं by the reaction of sodium nitrite and HCl. So such type of reagents which are prepared during the reactions are called as in situ reagent. Okay. Now this HNO2, it will react with this amine at 0 to 5 degrees Celsius, and it will form a salt that is called as ammonium diazonium salt. So by using this ammonium diazonium salt, we can prepare a variety of organic compound by using different nucleophilic reagent. Okay. If you use here copper chloride, when this copper chloride is react with this aromatic diazonium salt, we will get here this chlorobenzene as a final product. If you use here copper bromide, then bromobenzene will be the product here. CuCN, if you use here copper cyanide, then cyano, this CN group will be introduced on benzene. If we use here potassium iodide, then iodine group will be introduced to the benzene ring, and we will get here iodobenzene as a final product. And if you use here fluoroboric acid, then we can get here fluorobenzene as a final product. And instead of this nucleophilic reducing reagent, if we use hypophosphoric acid with water, then this overall N2 group will remove completely, and we will get here simple benzene as a final product. So this reaction is having very importance because we can prepare a library of compounds here, and the mechanism usually it proceed through ARSN1 reaction. So it is a type of nucleophilic aromatic substitution reaction, and in some halogenation reaction it undergoes through radical ion intermediate also. The next type of reaction given by amines is the formation of sulfonamide. Then when these amines, primary amine or secondary amine, they allow to react with sulfonyl chloride, then they give the substituted sulfonamide as a final product. Okay, this reaction is only given by primary amine and secondary amine. So therefore this reaction is also useful for the identification of primary amine and secondary amine in any structure. This test is also called as Hinsberg test, which is used for the detection or for the determination of primary amine and secondary amine in the product. The next type of reaction, that is second last reaction given by the amines, is coupling with diazonium salt. We can see here this aniline, when it allowed to react with benzene diazonium chloride. Again, ये कैसे बनाए होंगे अपन ने, अभी मैं जो प्रीवियस अपन ने स्लाइड में देखें, it can be prepared by the reaction of aniline and nitrous acid. So when this diazonium salt is react with this aniline, then we will get here this azo die as a final product. Okay, and what about the mechanism? This mechanism is proceed through aromatic electrophilic substitution reaction. So we can see here that this hydrogen atom is replaced by this diazo group. Okay, so it is a type of aromatic electrophilic substitution reaction. The next and the last reaction given by aniline, there are some more other reactions are also there, but we are seeing here, we are focusing on some important reactions only. So in this last reaction, it is a nitration of aniline. When the nitration of aniline is performed by nitrating reagent like nitric acid and sulfuric acid, then we will not get here single product. We will obtain here three product. We will obtain here para product also, we will obtain here meta also, and we will also get here an ortho product also. Why it is happening here? Because the aniline, in this aniline, it is having basic character, and nitric acid is having acidic character. So first, this simple acid-base reaction takes place here, and formation of anilium salt takes place. So this NH2 group will be converted into NH3 group. Now this NH3 group, it is having meta-directing character. It is having meta-directing character. It is having minus I effect, and it do not have any plus M or plus mesomeric effect or plus resonance effect. This जो कि यहाँ पे NH2 ग्रुप है, ये दोनों भी टाइप की इफेक्ट शो करता है, प्लस M इफेक्ट भी शो करता है वो, और प्लस R इफेक्ट भी शो करता है. ड्यू टू दिस releasing character or activating character, releasing character of this NH2 group, we will obtain here para product and ortho product. Because this NH2 group, it will increases the electron density on para position and ortho position, and it will attract the electrophile at para and ortho position. Whereas this aniline, during this reaction, it also form a salt with this by reaction with this nitric acid, and this salt anilium group, it is having meta-directing character. So it will attract this NO2 group at meta position. As a result, we will get here meta-nitroaniline also as a in major amount, in a very good amount. We can see here. We can say. So why here the ortho product we are getting here in less amount? Because of the steric hindrance. Because of the steric hindrance. So these are the different products obtained by the nitration of aniline. Okay, so I end here, and I am very thankful to all of you for listening and for your kind attention. Over to RF sir.
Thank you, all, sir. Bari, sir. Bari, sir.
तो वो लैंडर ट्रॉली में क्या सिग्नेचर
हाँ, बारी सर, आवाज आ रही है क्या बारी सर? Now, Abdullah sir, thank you. Lastly, I would like to thank Principal Dr. Mazhar Ahmed Farooqi, IQAC Coordinator Professor Aditi Bhattacharya, Vice Principal Muhammad Abdul Bari, and colleagues in the college as well as students. I thank all of you for your patience listening and participation. Thank you, one and all. Thank you.